And we're live. Hey, and Antonio's here. Hey, Antonio. Oh, all right.
Hello.
Well, shit, that was a hell of a start. Hey, welcome to another Midweek with Max. This is Rick, joined by JCV, Jeremy Nation, Marco, Antonio, Joshua, and of course our co-founder Max Sanchez. Let me turn it over to Max while I still have a voice, and he can walk you through this week's updates, and then we'll go over to Jeremy for some marketing updates, and then we'll get into questions. Just a reminder, because I wasn't here last week. So
All right, sounds good. Thanks everyone for joining another Midweek with Max. As a reminder, we do also have our protocol engineering office hours. I don't know why we always struggle with that one. Tomorrow at the same time, so this time, but tomorrow, if you're building something and you want to chat with us, ask questions, discuss ideas, anything like that, we will be live on same platforms, YouTube, LinkedIn, for some reason, and Twitter if you want to join us there. And aside from that, engineering updates, we've been making a lot of progress on ZK provability on the whole Rust stack. So we've gotten Oxygen pretty much finished up, and we're testing some optimizations for some denial of service style Bitcoin blocks that could take a long time to index in the ZK VM. And we're also getting that, we've got that wired into Opreth, and then we're getting our changes downstream to things like OpAlloy EVM merged in and working with our own fork of Kona, which then lets us prove with things like Kahlua and OpSuccinct for RISC-0 and SP1 respectively. And then we're also, after that, going to be working on a OpenVM compatibility port, so basically porting either OpSuccinct or Kahlua over to work with OpenVM and use the underlying Kona system. So a lot of progress on that front. We've also been making some improvements and fixes to the ZK Proving Marketplace. Marco's been working on a bunch of ordinals indexer stuff and some optimizations there. So we're getting closer to being able to start activating that in testnet, or at least DevNet, and playing around with some new HVM precompiles for ordinals. And I think those are the major items. So with that, I will turn it over to Jeremy first for marketing updates, and then we'll go over to Rick for questions.
You're on.
Hey guys, well, let me unmute myself before I start talking into
there you go.
the ether. This week we've got a report coming out that I've been working pretty hard on. I'm hoping that it'll get the final approvals, and then we've got a staging spot on the website, so keep an eye out for that too. We're going to have a brand new spot on the website for the reports. This will be the first one that goes up there, and then there's another report I'm working on putting the final touches on. There's some visuals and stuff that need to be added to it, so that'll be joining the first report that's coming. And after that, we've got some exciting stuff. We've got a new DEX partner coming this week. Keep an eye out for that announcement. And we'd also like you to take a look at Templar. Templar is one of the first cipher lending markets against Bitcoin out there. You can go to Templar's app, app.templarfi.org/markets, and search for Hemi. You can find the Hemi pools there. You can borrow and supply into that pool for different rewards. And with that, we can hand it back over to Max, who can start taking questions from Rick.
All right. Wait, I'm confused. Is it going? No,
Technically, he handed it to me, so I'll hand it back to you to ask questions.
Okay, thank you.
Yeah.
I appreciate that. I was
that's how it goes. I always hand it off wrong.
That's all right. I think we all handed off wrong. All right. Before we get into questions, I just want to say a special congratulations to Omni for winning Amigo of the Month for the month of June. Yes, June. It is July, right? Yes, it is still July. So therefore, that was June. So congratulations to Omni. We've sent you your exclusive merch link, and if you'd like to be Amigo of the Month, do cool shit in the Hemi Discord, and outside of it, build, talk about Hemi, make memes, do all that stuff. Get some
Hey
creative.
Rick,
and,
what do they win when they get Amigo of the Month?
You get a really cool hoodie. It's a really cool Amigo of the Month hoodie. It's actually available to the public, but I think we put it at like $15,000 or something outrageous, so no one will actually purchase it. You can win it. So I That's how that works. Well, I know we put like an exorbitant price tag on it just for shits and giggles. Uh, Regardless, let's get into some questions. Oh, there is a question. Um, let's see. From Mudakon. Do you believe Hemi will be the best environment for Bitcoin DeFi?
That is the goal. That's what we're working towards. I think, obviously there's tons of cool Bitcoin DeFi stuff people can already build with HVM the way it works today. But one of the big unlocks that I know we've talked about this in previous weeks, it seems like we kind of cover a lot of the same topics, but it's interesting and exciting. With the new HBit VM system that we're working on, most of that proof system, and with a few tweaks to the transaction construction. We're obviously going to use that for the Bitcoin tunnel, and that enables like on-chain Bitcoin DeFi backed by Bitcoin held in ZK secured vaults of Bitcoin. So for DeFi using Bitcoin as an ERC20, that's a big unlock. That's exciting. But beyond that, for more like, truly native Bitcoin DeFi, where you have things actually settling on the Bitcoin network itself, instead of, flying around as ERC20s and then eventually settling back in like large batches of unwinding ZK vaults and stuff. That enables all kinds of cool new native Bitcoin DeFi stuff, like being able to do Bitcoin-backed derivatives. So say, for example, you could write an options or futures contract where the flow of the Bitcoin out of the ZK vault that you encumbered in for that protocol is based on, say, an Oracle reporting clearing price at a certain point in time or something like that, and that settles natively on Bitcoin with native BTC delivery directly. You could also build new, cooler versions of a peer-to-peer Bitcoin DEX. So you could already do that with HVM the way it works today. So you could have a collateralized system where you prove you own some Bitcoin, you put it up for a certain price, and you put up some collateral against misbehavior. Somebody matches with your order. You have to deliver the Bitcoin natively on the Bitcoin chain to their specified address. But with the ZK-enabled ZK vaults and different types of transaction constructions, you can make that a lot more efficient, do some interesting things with it for things like ordinals or BRC20s, things that are outside just the normal Bitcoin protocol visibility. And then there's also cool stuff you could do with Bitcoin-backed stablecoins, Bitcoin-backed lending, and again, having all of that with pure native BTC encumbered on Bitcoin itself in one of these ZK vault constructions. That's, the flow of that Bitcoin out of that is controlled by like a control plane contract or something that you can run on Hemi with HVM, but you actually settle directly to Bitcoin at each step of the protocol. So short answer, yes, that's what we're building towards. You can do a lot of it today. And once we ship HBit VM and people start playing around with variants of those ZK vaults, that'll unlock a lot more cool, new, novel Bitcoin DeFi applications that you can't currently build today.
All right. Alpha, stop trying to sell your Amigo of the Month hoodie.
Hey, he's offering a 90% discount. I mean,
All right.
What a deal.
That's fair. That's fair. All right. We got a question that just came in from Awesome Chameleon. What does the HVM actually let a developer do that a normal EVM chain cannot?
Yeah, good question. So HVM, so I'll try to keep this quick, and we actually have a blog post. Jeremy, I owe you some final edits. I'm working on it. We have a blog post coming out. It's focused on Bitcoin ZK provability, but a lot of it touches on sort of the foundations of HVM, what HVM does today, how ZK provability improves that and makes it possible to do cool cross-chain stuff with Bitcoin. So if you're interested, that blog post will also have some interesting HVM-related bits and pieces as exists today, and then also with ZK, what kind of extensions or new ways you can use existing HVM features, the HVM precompiles, in interesting cross-chain compatible, ZK proven aspects. But short answer, basically, Bitcoin's architecture is, I've said limited in the past. I'll say it's not designed to work in a general purpose programmability environment. That wasn't the intention of the Bitcoin protocol, and that's not something that's going to be added to Bitcoin. So the structure of Bitcoin itself is very, you have to sync a Bitcoin full node in order to actually see important things about Bitcoin state. So when you look at Ethereum, for example, Ethereum has all of its state in a number of state trees. So you have the main EVM state tree, you have a receipts state tree. And those state trees basically authenticate everything about the current, state machine of the EVM, all the contracts, what address owns how many ETH, what's stored in particular contract storage, things like that. That's all in this one single state tree. And it's a Merkle-Patricia tree, which if you're familiar with Merkle trees, it's like that, but with a radix. So instead of having each node have 2 children, each node can have 16 children, and basically it makes the trees squattier and a little more efficient. And it lets you route like arbitrary keys to values as a key value store instead of a Merkle tree, which is unstructured. And so having all that state in that single tree lets you easily authenticate things about it. And so on Ethereum, for example, in a ZK context, you can easily prove that, this contract has this value stored at this slot in the contract, or this is the code for this contract that's deployed at this address, or things like that. And you don't even need ZK proofs theoretically. You could just do that with jagged extractions of the MPT tree, and you could validate those. But for more complex operations like running a function smart contract over a bunch of different pieces of data that's stored in that tree, you probably want a ZK proof for efficiency. But Bitcoin doesn't have a similar thing like that. So Bitcoin does have a state machine, which the largest piece of that you can think of as like the UTXO table, which is each Bitcoin block, you have transactions that spend existing outputs and create new outputs. So if I send JCV 0.01 Bitcoin, and then he sends 0.005 to Marco and 0.005 to Joshua, right? I created an output when I sent him that 0.01 Bitcoin, and then he spent that output and created 2 new outputs, one to Marco, one to Joshua. And so if you looked at the UTXO tree or the UTXO table, over time that would be evolving in each block where those transactions exist. So in the first block where I send it, JCV would have an unspent transaction output of 0.01 Bitcoin. And then when he spends it in his transaction, that creates the 2 to Marco and Joshua. In that block, you would now you'd remove JCV's 0.01 Bitcoin output from the UTXO table, and you'd add in Marco and Joshua's 0.005 Bitcoin outputs. And so the UTXO table is a representation of everything everyone owns on Bitcoin at a point in time. So as a Bitcoin block, 900,000, here's all of the scripts, the unlock scripts that control which Bitcoin, and then if you want to get into like ordinals indexers and stuff, you could trace those Bitcoin back all the way to where they're originally minted as part of a Coinbase transaction and see the whole provenance of those Satoshis over time with certain first in, first out, or similar like accounting mechanism. That UTXO tree is sort of analogous to Ethereum state tree. The UTXO table is analogous to Ethereum state tree, except it's not structured in a way that's cryptographically authenticated. So it's very hard to prove to somebody, I own 0.01 Bitcoin in this locking script as of the current Bitcoin block. Somebody could, I can prove that I received that 0.01 Bitcoin in some transaction, and I can prove that transaction was in a particular Bitcoin block that's part of the canonical chain, but proving that I haven't spent it is very difficult, because to prove I haven't spent it, basically the person verifying my claim would have to walk from the point the transaction was created and that UTXO was created for me, or for my unlocked script, and I have to walk the entire Bitcoin chain after that, checking to make sure that no transaction spent it. So super expensive to do. Ethereum, a very compact, even non-ZK proof, can prove, this address owns this many ETH at this block. On Bitcoin, without ZK proofs, that's basically impossible. So what HVM lets you do in its current form is, again, prior to the ZK proving work we're doing, is it runs that Bitcoin full node that can answer those questions inside the EVM. So contracts can call and they can look at whether a certain UTXO or whether a certain transaction output is spent or not, whether it's in the UTXO table or not. They can arbitrarily crawl through the Bitcoin chain without needing the person initiating a transaction to prompt multiple, proofs of different transactions that chain together and prove them against a certain canonical chain. So, for example, a transaction or a contract on Hemi, you could call it with a Bitcoin transaction. It could walk that transaction backwards to see, something about the history of the Bitcoin that's used in that transaction, where it came from originally, walk that, back, or walk it from a transaction, potentially walk it forward to see if it's later been spent in a certain way with certain conditions. And so things like that in HVM basically give you the ability in a smart contract to get access to Bitcoin data that's not cryptographically authenticated in any useful way by Bitcoin. or in any way that you can use for compact proofs. And so if you're building certain types of applications, like say a Bitcoin staking system, your system may need to check to see if Bitcoin still exists in a particular UTXO. And that's not something you can do with a Bitcoin like header only light client implementation running in an EVM. You can prove the output was created. You can't prove that it hasn't been spent yet. Similarly, if you're building something like, say, Bitcoin DEX, and you want to look at transaction history for a particular Bitcoin address, or in reality, a script or script hash, maybe you don't know the transaction that delivered the amount of Bitcoin that was required, but if you know the output where it was supposed to come from, you could check the spend status of that, follow that spend path forward to see if it was delivered correctly to the right participant in the system. So it makes it easier to build some things that you could build with a header-only mode system, so easier to program, easier to test and debug, and more gas efficient. But also it makes this new class of DeFi applications that require knowledge of the Bitcoin state machine that's not cryptographically authenticated to Bitcoin headers possible to build, to be able to look at the UTXO table, see if an output's spent or not, etc. Where ZK provability intersects into that is basically you can still have those same features, but now you can prove that the responses from those precompile calls were correct, again, with a ZK proof against a known Bitcoin state. And then you can use that for multi-chain settlement. So for chains that any chain other than Hemi that does not have a Bitcoin node embedded in the EVM and callable through these precompiles, you wouldn't be able to normally convince a chain like, Base, for example, that this precompile call with this data at this Bitcoin block returned this result. But with ZK proofs, now you can prove that, so you can use the responses from precompiles, cross-chain, and more importantly, what you're running on Hemi that interacts with HVM precompiles can be ZK proven end-to-end, so ZK proving the precompile calls themselves against a certain authenticated Bitcoin state, but also the rest of EVM execution. You can package all that together in a ZK proof and then deliver that to a remote chain and prove everything about the execution of a DeFi application on the Hemi network to a remote chain that doesn't know what Bitcoin is, doesn't track Bitcoin, certainly doesn't have a Bitcoin full node embedded inside of it.
All right. Still on the same or similar topic, where does HBitVM sit on the roadmap now, and what unlocks after the tunnel ships?
Good question. So timeline-wise, we're targeting hopefully Q3 for Ethereum ZK settlement, and then HBitVM is built on top of that. So we're probably targeting Q4 for HBitVM at the current moment. As far as what unlocks, it's a essentially trustless, permissionless, fully end-to-end ZK-proven Bitcoin bridge system or Bitcoin tunnel system. Its caveat is technically a one of n trust model, but you can be one of those n. So if you participate in the covenant emulation system, then it's fully trustless for you as long as you don't attack yourself, if that makes sense. So essentially trustless, permissionless, ZK Bitcoin bridging or tunneling to the Hemi network, and then through Hemi out to the rest of the Ethereum ecosystem. So as far as what it unlocks, it doesn't unlock new functionality for what you can do with Hemi BTC. It makes the Bitcoin settlement of Hemi BTC itself to Bitcoin fully trustless, permissionless, more secure with ZK proofs. But what it does unlock for developers who want to remix that technology into new things, which I kind of already covered earlier, but you can take that same HBitVM proof system, which is basically an end-to-end way to use Ethereum proof of stake and Bitcoin proof of work to keep each other in check, to establish a way to create a censorship-resistant view of Bitcoin using Ethereum proof of stake, and then use Bitcoin proof of work to make sure that somebody can't fake out that system with creating a minority consensus power fork of the Ethereum network and then privately ZK prove that. So basically you have a Bitcoin proof of work and Ethereum proof of stake secured ZK proving system that can prove anything about Ethereum, Bitcoin, or the Hemi network, or you could extend it to any Ethereum DA derived L2 as well. And then it combines that proving system, which is how you get those secure self-contained proofs. And then it allows you to use those and validate those on Bitcoin itself to control the flow of BTC that's locked in it's a little more complicated, but we refer to it as like a ZK vault. It's a DAG of Bitcoin transactions that are all created with covenant emulation that enforce certain flow control rules that ultimately result in the optimistic verification of a ZK proof. So as long as, again, one of n of the covenant emulators is honest and somebody is paying attention, acting economically rationally in the system, you cannot move funds out of a ZK vault unless you produce a ZK proof that is effectively verified through that optimistic verification process on the Bitcoin network itself. And so you can build all kinds of cool constructions around that. So we're using it obviously for our Bitcoin tunnel. But as I mentioned earlier, you can use it for things like native BTC cleared options and futures contracts. So more advanced, more sophisticated direct on Bitcoin derivative systems. You could use it for Bitcoin-backed lending protocols, Bitcoin-backed stablecoins, new forms of peer-to-peer Bitcoin dexes. There's probably other use cases that we haven't thought of, but those are the most exciting ones that I think are interesting, would get, adoption and use from certainly retail. And then if we can get the proof size is small enough, like BitVM 3S style constructions, those to be, usable by retail in a more like economically reasonable fashion, because the fees for BitVM vaults and settling them on Bitcoin, especially in the worst case where you have to go through the optimistic fault dispute process in the verification of the ZK proof, can be relatively expensive depending on Bitcoin fees. So it certainly works great for institutions where maybe you're writing a options contract for 10 or 100 Bitcoin or something like that as a treasury management tool, or with BitVM 3S and circuit garbling and being able to basically trade the cost of on-chain computation for off-chain storage. That could be reduced to low enough fees that, in reality, somebody could maybe use that for a 0.1 Bitcoin options or futures contract. And so that'd be more of a, retail accessible version of it that requires a little more development of the technology, a little more infrastructure around it for handling all that off-chain storage securely and making sure that it's accessible. But that's sort of you have HBitVM as the tunnel technology that makes Hemi BTC fully backed by Bitcoin. That's ZK settled to the Bitcoin network. And then you have remixes of that technology to build other cool Bitcoin native DeFi primitives that don't use Hemi BTC, but they use the same underlying tech to build these options or futures contracts or Bitcoin-backed lending markets or Bitcoin-backed stablecoins, all of those protocols by reusing the tech and basically changing the on Bitcoin transaction structure, but reusing the same proof system.
All right. Alpha, I see your question regarding Guild. I don't have a concrete answer for you right now, but we are having a pretty robust meeting regarding that tomorrow. We are targeting Zeely, though. I can say that. And I hope to have a much better update for yourself and the community next week, if not the following. But it took months to build, and if you've been part of the beta test for the guild, you will notice that many things are just not working, and therefore, yeah, a change is going to come, and Joshua, JCV, and myself are going to figure that out, ideally tomorrow. So I'll have more info for you next week. I didn't want to leave you hanging on that. All right. The sequencer is a single operator today. What's the concrete path and timeline towards decentralization?
That'll be post HBitVM, so probably call it Q1 of next year as a rational target. As far as the path and the on the tech side, the plan for it is essentially adapting Ethereum proof of stake style consensus to an L2. So there's a couple changes, relatively minor, but there's a lot of work stitching it into work with an L2, but the actual protocol itself and the way that it functions and the economics of it will be very similar. One of the big changes is, since there's not a protocol native, well, there's a protocol native, ETH gas token on the Hemi network, but that's not the token that we'll use for consensus. It'll be using obviously the Hemi token, and that's going to be through the VE Hemi staking system. Ethereum's proof of stake system has to be adapted to use VE Hemi positions and respect the relative time lock weights of them, which is something that the normal Ethereum proof of stake protocol doesn't deal with, because it just has ETH locked up for a sequencer on the network, and it's a perpetual lockup instead of the timed gated lockups of VE Hemi. So there's some changes to how weighted positions are treated in the system, but essentially it's Ethereum proof of stake end to end. So it'll be the flow would be, you would go in, you would stake a minimum amount of Hemi tokens as VE Hemi, or a little more pedantically, you'd get a minimum stake weight in VE Hemi. So that could be, and I'm not saying this is the number, it'll be probably quite a bit higher, but say it was 100 Hemi tokens for a year. So that'd be a 25 Hemi token stake weight initially. You could stake 100 tokens for a year, 200 tokens for 6 months, 50 tokens for 2 years. Those would all give you the same stake weight in the system. And as long as you stay above that minimum stake weight from all of the positions that you've restaked into the proof of stake system, then you'd be allowed to run a sequencer. And then depending on how many multiples of the minimum stake weight you have, that's how many slots essentially in the overall system you get. So kind of like Ethereum with the recent well, not so recent anymore, but the upgrade from having a minimum stake or increasing the minimum stake that you could have for a single node up to 2048 ETH. It'd be a similar mechanic where you, as a single address in the system that is acting as a sequencer, if you had, say, and again, say the number was 100 Hemi tokens for a year, so that's a 25 VE Hemi token voting and consensus weight. Then if you had, say, 76, you would get 76 divided by 25 rounded down, so 3 slots in the consensus protocol. Similar to Ethereum, if you staked, 96 ETH, that would give you 3 slots with the new or semi-new Ethereum consensus rework to support those larger stakes natively. So basically take that idea, bolt that onto VE Hemi, use VE Hemi voting weight as determining in aggregate for all your positions across your account what your weight is in the system for how many slots you get per, basically, it's not a full rotation, it's not like a round robin between all participants, but in the sampling, the random sampling of which validator is able to create the next slot, that would be based on your weight of that multiple of the minimum stake weight versus everyone else in the system who's actively staking. So based around VE Hemi tokens or VE Hemi staked positions, and then your consensus weights based on the value locked up times the amount of time that's locked up, instead of Ethereum's single, just the amount of ETH locked up, but otherwise essentially the same mechanics. And there's also a way to reuse RANDAO from Ethereum to make our system more secure against like random disk manipulation, but that's kind of a side note.
All right. Let's see. Last week, you mentioned a demo of the ZK marketplace in development. Can you show that today?
You know what? Let me see if I can get that. I have a couple patients open, but let me see if I can run the current version. And why don't we go on to the next question? I'll try to do that in the background and see if we can get that working.
All right. Is Vetro and Hemi's development teams the same?
We share some resources for some of the smart contract development, but a lot of the smart contract development in Hemi is basically coming out of protocol engineering, so that's not really shared. I'm involved in Vetro to an extent, working on some cool things that I find interesting, but in general, they are separate teams. So protocol engineering, DevOps, SecOps helps with a couple things on the Vetro side, but they're essentially different projects with mostly different teams. And as Vetro kind of comes out of this initial, I don't want to call it beta because it's live in production on mainnet, but out of this sort of initial launch path, and it becomes its own project, it'll be more and more of a separate team as the project develops more.
Should I ask another question while you're looking
yep,
at the
go
ZK
for it.
demo? Okay. that was a lot quicker than I thought it was going to be. All right. How will the
so the trick is to have Max typing?
Yeah, the trick is to have me distracted with the ZK marketplace.
Right. Okay. Well, why don't we talk about ordinals, Marco, for like 5 minutes, and
that'd be perfect.
What he's doing.
Okay, so we can talk a little bit about ordinals. So let me give you guys a little bit of an update. Max keeps calling me stupid that I cannot write code that runs fast enough. So I've had it with it. So I finally fixed all the performance issues that we were having. So ordinals are, all jokes aside, incredibly heavy. Mainnet really punched me in the teeth when I started testing it versus testnet and other things. I just had no clue just how bad and how much used ordinals are actually in the ecosystem. So one of the problems was that some blocks would take well over 10, sometimes even 20 seconds to be indexed. And of course, our HVM is clicking at every 12 seconds, so clearly that was never going to float. So that required a little bit of a redesign, and so I went back but I actually found some real performance issues that I actually had introduced myself. For example, I still had a diagnostic in there, which I always have when I write the code initially. So I had a diagnostic that would panic if something weird happened. But that diagnostic was incredibly expensive. So removing that helped quite a bit to speed it up. There were some other caching tricks that I could play. So what it boiled down to is I added all kinds of clever bits of code to minimize disk I/O, because the entire name of the game is disk I/O. So and there's two modes. When you're in IBD, you're just basically downloading very large blocks of data and inserting it into a database. And as these databases grow, the amount of I/O every now and then explodes, because now you have to essentially flush everything to disk and create new files, and it's just a giant pile of work, and actually a giant pile of I/O. And it turns out that actually a lot of the performance issues we were seeing was because of compaction, database compaction. But database compaction pretty much only happens during IBD all the time, because you are inserting large amounts of data, and by definition, you're going to be compacting quite a bit. So the insight there was that what matters is really what happens at tip. So as long as we can insert these blocks, sub 3 seconds, we are going to be fine, including it in the HVM. So the goal became, how at tip, how do we get to sub 3 seconds? And at this point, I think we have reached that goal of being pretty much always sub 3 seconds. I'm sure there's going to be an outlier here and there, but if you run a whole bunch of different machines, one of them may be a little late, but it doesn't really matter because the majority of them are on time. So anyway, so it was quite a fun puzzle to go solve. And now I have some ideas, and maybe I can actually make the UTXO and the TX indexer work a little faster, because I did learn a thing or two along the way. So yeah, it's been a hilarious puzzle, fun to work on. And yeah, so if you want to see some fun performance code, go have a look at the ordinal PR, and tell me what I did wrong. All right, Rick, do you have an actual question about ordinals now that you have an update on where it's at? So, and at this point, I think we are actually ready to start moving it to testnet and mainnet. So the PR is at production, near production ready.
Yeah, we have a couple housekeeping items around testnet. So Ethereum is deprecating Sepolia, but it's unclear when, and there's not a replacement testnet for it yet. So in parallel, a lot of the ZK proving stuff that we're testing out, we want to do on Hootie testnet, because that has like actual real Ethereum consensus running, which is something that we need for part of the ZK proving for HBit VM for the new POP upgrade to publish data from Ethereum consensus, basically the Ethereum stripped Ethereum attestation data to Bitcoin. And so you can't really do that with Sepolia, which is not a proof of stake network. And so we're trying to figure out the plan for, in addition to just getting ordinals in a place where we can test it, people can play around with it, beyond just like local dev nets. We're also on the macro trying to figure out what to do with the Hemi testnet, whether we don't know if Ethereum is going to upgrade Sepolia for the upcoming Glamsterdam upgrade. So if it gets deprecated before that, obviously we have to move fully off to a new testnet. If they're going to maintain it, but in some sort of like deprecated mode, that changes things a bit. But we do also have this other need for the ZK proving stuff to run on a network like Hootie. So I think we talked about this in previous weeks, but there may be some changes or deprecation of the Hemi testnet, depending on how exactly Glamsterdam shakes out. and then also depending on whether we make the ZK testing testnet that we're going to be deploying on Hootie something that's publicly tested, or whether we're going to try to just test those pieces in isolation and keep on the Sepolia network. So there's things to be figured out on the testnet side, but none of that blocks necessarily enabling the ordinals indexer on the current testnet for people to play around with. But just be aware there are testnet changes coming if you're paying attention and playing around with stuff on testnet.
It's called Glamsterdam?
Yes, it's called Glamsterdam. John, would you like to chime in?
Wait,
It sounds like a drag rave in Norway. Like, what the hell?
So
What the hell is
Glamsterdam gives you
Glamsterdam?
pause, but Hootie is totally fine. That one doesn't.
Well, that
I mean,
evokes many blowfish vibes, does it not? I mean,
It
like,
does. That's the only thing I hear.
I was picturing the owl who eats the Tootsie Roll Pop.
Yes. How many confirmations does it take to get to the center of your transaction?
Basically, who the hell's naming
3.
this shit?
Chomp.
Apologies if it was like one of you guys, but man, who the hell named Glamsterdam?
I mean, look, we're not good at naming. We'll admit it, but we wouldn't.
Wait, no. Speak for yourself. I'm great at naming.
Debatable. Do you want to go over some here?
Yes, I do.
I think this is a great segment.
I
Let's
think this
hear
is a
some
great time to go
names
over
from
those
Marco.
names. Hit him, Marco.
Well, I want to say one of the ones I'm most proud of is that I created a window manager that I called Scrotum. That was pretty awesome.
Triple X term is also in your greatest hits.
Yep, it is. And, let's not forget, the Continuum Transfunctioner. No, I win this.
BFG for...
Yeah, BFG. Yeah, you're welcome again.
Continuum is a cool name. I like that one.
I
BFG
also
was
like
funny.
the Bitcoin Finality Gadget. That was a good one.
Larry.
It was great.
Yeah,
Dave.
Larry. We
Yeah,
have Dave.
fantastic.
Dave, the backup guy.
Oh, man.
Larry, the database guy.
I mean, they're better than Glamsterdam. There's no getting around it.
See, there we go.
Ethereum has had some wonky names for its various iterations.
They have.
Who came up with like the soda naming convention? Because isn't there like Ethereum and like Ethereum Classic? Like,
Ethereum Light.
yeah, so it's like Crystal Ethereum. Like, why not? Like,
Ethereum Lite is part of the upcoming Ethereum upgrade that makes light clients more efficient. It's on brand.
Okay, so I guess we need Cherry Ethereum at any moment now.
Vanilla. Or was
We
it
could have an
Vanilla
Ethereum
Cherry?
Zero.
Ethereum Zero. Oh, man.
All right. We've gotten really off the rails, and I don't even know where the hell I am right now.
Wait,
We were talking about awesome names for products that is not a Glamsterdam.
We're
right,
filibustering
here we
while I try to get the ZK market proof running.
All right, I'll direct this one towards JCV and Marco, so Max can continue pulling up the ZK thing. How will the team focus on refining Hemi further, and how does that work?
I'm gonna let John take this one.
I'm not entirely sure what we would mean about refining Hemi, where, we've spoken in excruciating detail about some of the upcoming things that we're working on at Hemi, to the point that I would assume you people don't even want to hear about them anymore. But between the various ZK work and, we know further decentralizing work is, remains a big and important thing on our, I don't want to say roadmap, because we don't have a document that we point to as a roadmap, but those are the high ticket things we're looking at and actively working on. Do those count as refinements? I don't know. Probably not. I don't know if that's how. I don't know if that's.
Well,
that's
the
how
sequencer is a huge deal, though. So the
That is-
decentralized sequencer is definitely a black eye still. And that one I really want gone.
That is such a big one, and that's so important. But it's not a refinement. It's
Oh no, that is definitely a refinement. And actually, let me be ugly for a second. So I have been pushing unsuccessfully so far, although I do think that Clayton is going to like it at some point. So I want to shed our OP skin. So we still have too much optimism, dependency. We care too much about what they do. And I have been advocating to get away from optimism altogether. So thank you for the code. We use it for a while, and now we are going to start replacing bits and pieces with code that we trust and we like better. I don't feel that they've added anything new or valuable to the ecosystem in a while. So, but we are paying the tax to maintain it in our stack. So that's the other thing that I would like to go attack. So if that's not controversial, hit it.
And there's also, as far as what I'll avoid the term roadmap, but a plan for doing that looks like as we decentralize the sequencer, that basically replaces everything, every important bit and piece of opnode other than like maybe, block derivation and a couple of things that are like easy to port or replicate. So opnode's probably the first target to replace, and that would be probably as part of the decentralized sequencing upgrade. We're not going to try to like backport a brand new decentralized consensus protocol on top of opnode. That's where it makes sense to like diverge and build our own consensus layer client. The execution layer client is a lot trickier to replace, and there's less of a good justification, although it'd be nice. So that one's probably a little later. And then things like Proposer, Batcher, all those can probably go along with decentralizing consensus and decentralizing data publication. So the goal is with decentralized sequencing and kind of its related friends of features, we could probably move to just where maybe the execution client is still based on upstream optimism with all of our HVM modifications, but that everything like the consensus layer up is our own custom stack. But things take time, but that's where we'd like to get to, in the next couple of quarters here.
Yeah, like I'd speculate that the last bit that will remain from that stack is that we don't want to be supporting to fully support an execution client, namely either Geth or Reth, is necessary in the sense that now there's not just our changes, but there's keeping up with the upstream Ethereum hard forks. And even though those don't happen super quick, that there's a lot of, you almost need a full team to do that. So that's one that I don't anticipate us completely adopting on our own at any time in the near future. But the other parts, yeah, I mean, the sequencer is a good place to start. And if that's where if that's where we finally cut the fucking cord and do it, that's
and
great.
Go away.
Yes.
And also that's the daemons, but there's also the smart contract side. And as we build out like the ZK Ethereum settlement system, probably the initial version is going to be based on the existing Optimism contracts, but those are going to evolve to the point where they're, basically just our own version of that we're maintaining. We're not inheriting any of their upstream improvements because they're orthogonal to what we're doing. They're, updating things with the fault dispute game. We're not using that. We're using ZK settlement. So that's a point where it'll be still based on the core framework of how the Optimism Ethereum, bridge or tunnel contracts work, because we need backwards compatibility with the existing system as it's deployed. We don't want to make a breaking change and like force everyone to migrate from an old version of assets to a new version, because there's no good reason to. But that'll become our own fork off of a point in time where the structure is, which has already been settled, the structure is settled, and then we're developing our own stuff on top of that separately from what Optimism's doing. So the contract side stuff it'll have the Optimism original DNA, but it'll be the kind of thing that we can fork off at a certain point and just do our own thing independently, because we don't need any of Optimism's features related to fault dispute games or things of that nature. And I did get the ZK demo good enough to show off. So let's see if I can screen share. That's the next challenge here. Let's see here. Share screen. How is this going to work?
It should work. We had it work when we did the NFT marketplace, Mintora.
All right, let's see here.
Okay, so whatever replaces optimism, can we call it pessimism? Just as just as a shot?
Probably not. Probably call it I don't know. I can't come up with a good thing. The origin of the name Optimism was optimistic verification, which with the ZK, direction, there is still technically the optimistic fault dispute process on HBitVM for Bitcoin ZK proof validation. I have so many windows. I'm sorry. I will find this in a second.
Can we call it irrational optimism?
Yeah,
No,
we should actually give this to Clayton though, because poor guy has suffered through most of the op stuff, so he gets to call it whatever he wants, and it may be offensive.
Now let's call it the
Oh,
apathetic one. You just don't care if it's confirmed or not. And we'll call it the app layer. You see the apathy layer. So that's what we'll do.
So Marco, if he wants to call it Cincinnati chili, would that be too offensive in your opinion?
No, he deserves it.
So there's a dish here it's called a three-way. It's spaghetti, chili, and cheese. I think the four-way has onions on it, or I could be mistaken. I could be mixing this up, but we could use one of those names to refer to the food, of course.
Talking spaghetti casserole over here. This is starting to get right up into my alley.
All right, it is actually really good.
You people upset me.
There's an Italian on this, right?
There's two, and I'm also very offended, just for the record.
It's not my fault. I'll eat anything.
All right, is that screen share working?
No. Oh, yes,
there we
it
go.
is.
Yes.
Otherwise, we were going to ask you to act it out.
Do an interpretive dance.
Yeah, pantomime it.
Please do an interpretive dance of the ZK marketplace demo.
Oh God. Thank God the screen share worked. If that was the alternative. Okay, so where do I start? Let's see. So this is the user interface is a work in progress. I'm not a UI guy. This is just sort of what I put together because it makes sense to me. But there will be improvements, and part of the community beta testing will be feedback on like actually making this usable and have the data people care about, and so on and so forth. But the cool thing is it shows all the pieces of the underlying system, how everything kind of fits together. So starting from the top, well, first I'll put it in demo mode just so you see like a more realistic version of this. Is all like mocked data, and then we'll go to the live version, actually look at the ZK miner and how that works. But this is a little easier to explain how everything flows through because it's a little more active and you see stuff going on. So this is mock data, but this is what it'd look like if there was like an active ZK proving marketplace with a lot of traffic that this was connected to. So you have multiple different, one of the big things with the ZK marketplace that we're working on, I'll go back to the dashboard and talk about stuff there in a second, but it's being able to support multiple different ZK VMs natively and be able to let people permissionlessly add, let me zoom in a little bit. I just realized it might be kind of small for some screens. Permissionlessly add new ZK VM implementations. So there'd be a governance process data behind VE Hemi that approves, formally new ZK VM verifiers. And so they'd show up as like, governance approved, but the system itself is permissionless. So anyone could add, if you're the developer behind one of the developers for Jolt or something, you could add a Jolt ZK verifier. And if people go and look at it on chain and verify that it's correct, they could use it through the marketplace without needing to get anyone's permission. And then governance could approve it as one that, shows up as like a default in the UI and stuff like that. But currently, the way the system's built, it has the three we're focusing on first is SP1, RISC-0, and OpenVM. Right now, the live demo I'll show you in a second is SP1 and RISC-0. OpenVM is supported, but we're still adding support for that to the ZK miner, so it's not fully tested yet. But basically, so this would show you which proof system adapters or proof verifier frameworks are enabled in the system. These are the ones that are deployed and governance approved. So these are the, official ones that are safe to use, and then other ones could be, again, permissionlessly added that people could use if they wanted to, but they wouldn't show up by default on the UI. And then you can look at different programs. So each program is basically a ZK VM guest program that's a target. It's code that's compiled and targeting a specific ZK VM version. So you could have the same, Rust program like the EVM state transition function, but you could wrap it in RISC-0 and an SP1, wrapper that works for both those ZK VMs, and those would be two separate programs. And then you can, I'm not sure if we have it in the mocked demo, but some of these, let's see here. Yeah, it doesn't show up in the UI, but on the back end, you can cluster programs together. So you can say, these 3 programs are the same functional program, but they're compiled for different ZKVM implementations or ZKVM versions. So you could have the Oxygen ZK Prover, the Oxygen state transition function ZK Prover guest program compiled for SP1 and RISC-0 and OpenVM, and have those grouped together. So you could look at, combined statistics for all of the ZK-proof jobs that are all of the ZK-proof job requests that are being submitted and fulfilled, and look at the clearing price for those relative to that specific application or functionality grouping. But this is just for one. So this is this is mock data in this example, but this would be an Ethereum block proving ZK VM guest program. So this would be the image ID, or depending on which ZK VM system you're using, it's called different things, but basically this is the compiled ZKVM guest program. That's the hash of it. And then you can look at statistics for how many jobs have been submitted, how many of them have been fulfilled, how many tokens have been paid out through the system for people who fulfilled it. You can use price history to look at just the history of cost for executing this ZKVM program that was basically the market clearing price. So we'll get to this in a second, but the way that jobs work is you submit them as different types of auctions. And so you don't submit a job and say, you can, if you want, you can have a linear auction, but you can say, or a flat auction rather, but you say something like, I want this program proven for these inputs or with this output. I'll talk about that in a second because that's cool. But the bids start at 20 Hemi tokens, and it'll increase over the period of an hour up to 500 Hemi tokens. And then it's basically a reverse auction where people who have ZK proving compute available, once one of them decides it's worth it to claim that job, they claim it and fulfill it at that price. So that establishes a market clearing price for ZK compute. And then there's a couple different things in the system for being able to standardize that compute cost into a price oracle for ZK compute for each of the ZK VMs respectively. So basically cost per cycle count over time. And that part requires RISC-0 has a system in their ZK VM that lets you, as part of the proof, easily prove the cycle count of the program. SP1 and OpenVM, you can get the cycle count in the program and you could journal it. So you could commit to it as part of your ZK proof that's authenticated by the proof, but there's not a standardized way to do it. So the market would need to know, this particular ZKVM guest implementation is going to journal the cycle count at, this byte offset in the journal or something like that. And so that makes it a little trickier to standardize. So we have another system, which is based on VE Hemi governance, basically people who stake a bunch of VE Hemi tokens and then in a blinded fashion commit to their view of the compute complexity of each job. And then so it's a commit reveal system that can then be used as basically a governance enforced way. And it's not important at the contract layer specifically, unless you're doing cycle-based job pricing. But it allows basically the market to establish a public stats for the clearing cost of ZK compute for different ZK VMs across all of the guest programs in a way that doesn't require the ZK VMs to adhere, or the ZK VM guests to adhere to a specific output structure where they journal the cycle counts. For RISC-0, you don't need it because it is standardized, so you don't need that Oracle system. But anyway, so this would be an example program. So the Ethereum blocks ZK VM. This one works with OpenVM, and there's obviously always a version with the ZK VM. And you can see which jobs are submitted. The job lifecycle, which I'll go back to the dashboard for. This proof supply chain probably needs a better name, but that gives you an idea of how proofs flow through the system. So submitted is when somebody submits a job to the marketplace. Open, things very quickly go from submitted to open. There's an optional delay that you can add to submitted jobs to say that they're not active for, say, 60 seconds to give everyone time to, simulate the cycle count or simulate the ZKVM guest execution, verify that they can actually execute it so that you don't have people bidding on jobs, not sure if they can properly fulfill it. So there's an optional delay, which is the difference between submitted and open. If you submitted something with no delay, it would go immediately into the open category. Locked is when someone reserves a job, so they stake Hemi tokens temporarily to say, I want to fulfill this job, I'm going to work on it. And then either if they fulfill it within the time specified by the person submitting or the protocol, submitting the ZK proof job. Then it would go to fulfilled. The user gets paid the number of tokens that they should get paid according to where they landed in the bid in the auction for the completion of that ZK proof. So when they locked it, they locked in a price. So say it was a linear auction from 20 to 50 Hemi tokens, and you locked it when it was at 30. No matter how long it takes you to prove it, as long as it's within the proof delay that the job submitter attached to that job, when you eventually submit the valid ZK proof and it validates on chain, that's going to be a fulfilled job, and you get paid that 30 Hemi tokens, which is the value you locked that proof auction at. If you fail to submit a proof within the timeout, then it goes into slashed, where you get a portion of the collateral that you put up to lock the job gets slashed, and then the job gets resubmitted to the market so that somebody else can bid and lock on it and fulfill it. And then timed out is if nobody, say you submitted a job that was way too cheap for anyone to bother fulfilling it, no matter how long in the auction it goes. Say you had a max cap of 20 Hemi tokens, and it took somebody 3 days worth of GPU compute to prove a ZK job. Nobody's going to claim that, so then that would eventually time out. And so that's sort of the pipeline of jobs come in, somebody locks them, they either fulfill it or they fail, and then it goes back into the queue. And if it never pays enough for somebody to lock and actually fulfill it, then eventually goes into the timed out category, and it could be resubmitted, or you could have handling for that. And then, so there's just kind of we zoom out a little bit because there we go. So this shows you a little bit of how the Dutch auction works. And so let's do this one as an example. So let's do this one because it's easier. So this would be a linear Dutch auction that starts at t = 0. So not when you submit it, but after the timeout, when the job is now active and available for bidding, it would start at a price of 5,074 Hemi tokens, and then it would increase linearly over a period of a little over 40 minutes up to a maximum of 21,865 Hemi tokens. And so the idea is that somewhere in this curve would be the market clearing price, where somebody is willing to lock that job and then actually run the compute to ZK prove it. And then over here you have an applications leaderboard breakdown. So this is basically looking at what ZKVMs are using the most, what ZKVM guests are using the most compute in the system, and how much they're paying for it. And so you can look at how much they're spending, and then how much compute they're using, again with RISC-0 that's built into the proving system. With SP1 and OpenVM, that's a separate compute complexity thing that the VE Hemi stakers in the system would attest to in that blind commit reveal fashion I talked about. And then here you can look at more details on a job. So say this is a proof for an HBit VM withdrawal is the example here. You can see this auction is quadratic instead of linear, and there's reasons to do that depending on how you want to engage with the marketplace. So you can have different curve shapes that you define. Well, you can choose from a list of approved curve shapes and then set the parameters for them before the auction goes off. So usually auctions will increase up to a point and then stay constant at that for the duration of the job before it eventually times out. So usually the expectation is somebody would claim that somewhere along the initial growth curve. But say there's a huge flood of ZK proving work, maybe nobody gets to this job, even if it makes sense economically for them because they're busy doing something else. So they might claim it later once the proof job's already reached the maximum plateau pricing. And so if you look at, say, one that's locked, you would see that when it got locked, in this case, visually it's not a great example because in this example data it got locked almost instantly, but you'd see the actual theoretical curve, and then you'd see where the job got locked at. So where somebody locked in the current state of the auction to reserve that job to then go and ZK proof. And then let's see if we have, let's look at a fulfilled one. So this would be somebody locked it. You can see where they locked it, and then how much time it took them to fulfill it. So this one, and again, mock data, but this one took them 14 and a half hours to fulfill it. So it was before the proof deadline. So you can see where they locked in the auction, and then on that same timeline where they eventually fulfilled it, and see all the payout information. Auction parameters, that's where like the curve parameters and stuff like that are set. So Dutch auction, whether it's quadratic or linear, and then ramp up timeout, all of that is the shape of the curve, the duration of the curve once it reaches the maximum, and then the collateral requirement that somebody needs to put up to reserve the job. So if you wanted to overpay for people to put up more collateral for your job so that you are more confident that they're not going to abandon it. Say for a system that needs faster turnaround times for ZK proving, you could have much higher collateral requirements, which mean only that the people promising to ZK prove your job are taking more risk if they fail to deliver the proof in the required amount of time. And since it's an open peer-to-peer marketplace, you can define any of these parameters however you want and engage with the market in different ways that get you different, quality versus cost trade-off of ZK proving. And there's also a way that you can have multiple auctions go in parallel. So if you needed, say, a proof with, a lot of redundancy really quickly, you could way overpay to have multiple people do the ZK proof at once so that at least one of them successfully completes the job. And then job details, what program is actually running, if it's been, it failed in the auction, had to be reopened, things like that. This is a little redundant. Some of the auction config we already looked at, stuff of that nature. And then this is just for testing, but this allows you to actually submit like contrived ZK proof examples to the marketplace just to play around with it. Prover panel. So if right now I have my wallet linked, and so this would show me how my prover that's working in the system is functioning. So how many tokens I have staked, and whenever I reserve a job, it's taken out of that staked portion, and so it's locked and staked. So right now I have, in this example, 12.5 thousand Hemi tokens that are actively locked in jobs, 37.5K left that I could use to lock additional jobs. And then as I fulfill some of the jobs I locked, these would go back into the available collateral and I could reuse it for new jobs. And then this is obviously how many Hemi tokens you earned when you last submitted a proof, earnings over time, job completions over time, slashing if you failed to deliver jobs in time, then a portion of your collateral got slashed, things like that. Then you can manage, staking more or withdrawing tokens from the system. You can see which jobs you have claimed. You can delegate to an operator. And so that could either be you're delegating to yourself if you want to run certain constructions where it makes sense, is like you have one wallet that has a lot of assets in it, and you want to keep that key really secure, but then you want a live operator to be able to actually programmatically interact with the ZK proof system with the ZK miner, claim jobs, submit them. So you could delegate, you stake your million Hemi tokens in your very secure, hardware wallet account, and then you delegate to an EOA that just has, $5 to pay ETH gas fees on the Hemi network, but it's able to claim and submit jobs on your behalf using your stake in the system. So it's a way to either separate that out, or in the future, people could create like ZK pools. And so you could delegate your stake to the operator of the ZK pool and then get a portion of the pool proceeds for providing the collateral for the pool to operate, stuff like that. We go into more details, but that's basically the management. This is just sliced versions of that overview page at the moment. Analytics shows you more detailed market stats and performance leaderboards for provers, requesters, different programs, a lot of the same stuff we saw on the dashboard, but more granular detail. And then there's a profit calculator where you could choose. There's not a lot of, there we go. You could choose which GPUs you have. We're establishing, and this is still a work in progress for figuring out the best methodology for this, but a generic cross ZKVM measurement of compute performance for hardware. It's not going to be perfect because some ZKVM execution clients are more constrained with memory bandwidth. Some of them are more constrained with, in32 compute or whatever. So it's not perfect, but it lets you kind of benchmark hardware and do sort of an apples to apples comparison across, different GPUs, different GPU generations to get a rough estimate of how well they work for ZK proving. The ZK miner benchmarks per ZKVM, so it can optimize a little further than this like higher level cost calculator. But basically, you choose whatever hardware you have, and it would show you the throughput of your total system, estimate of how much you could earn per day. So it's supposed to kind of, if anyone here was part of the GPU mining days, way back in the good old days of crypto, this is sort of analogous to that, but obviously for using it for ZK proving instead of proof of work. So now the cool part, I'll switch over to the actual live demo. So this is live running on Hemi testnet. So I just spun this up while we were on the call. And basically you can look at jobs. These are real jobs being submitted. And so submitted, becoming open, getting locked, and then getting fulfilled by a real ZK miner. So I'll switch over to that and show you what the ZK miner itself looks like in a moment. Right now, for testing purposes, the curve is very short. So it's not a great visual, but basically it had a very quick curve and it got claimed partway through that cost increase curve as part of the Dutch auction in this case. Again, that's more testing. This is like a live prover panel of actual, this is obviously testnet with, you know, a fake ERC20 for testing, but total number of tokens staked, what's actually available versus locked in the system for the job that we claimed. If we were to go and then look at the current locked job, you would see that you can see the auction economics, and then I believe on here you can also see how much collateral, locked collateral there, how much collateral is actually locked to claim this job, and that's the default 150% collateralization to payout ratio. And yeah, I think that's pretty much it for the UI. So most of the stuff we went over in the mock-up, there's no reason to repeat that with the live demo. But the cool thing is, let me switch my screen. Let's see if I can figure this one out. Over to the ZK miner. Where did I put it? Give me a second. Here, okay. Share screen. Okay, let me find this window. Sorry, 1 second. I've got way too many terminals open. There we go. It was already all the way at the bottom of the list as expected. So this is a version of the ZK miner currently. There are still some usability improvements to make to it as well, but it shows you all the... I see everyone like joining and leaving. Is there an issue with the stream, or is everything working?
Everything is working. Joshua just moved people backstage, so that way it wasn't like clogging the whole screen.
Got it. Okay, cool. Just making sure things are working. Okay, so this is the ZK miner. So this is a application run on your machine that has hopefully GPUs. It can also just run on a CPU if you want. But this machine right now has a mix of AMD and NVIDIA GPUs. So it works both for it works for AMD, NVIDIA, and Intel GPUs. We've ported, or in the process of porting, we ported RISC-0 to AMD and Intel. We ported SP1 partially to AMD, that's in testing, then Intel's next, and then we'll do the same for OpenVM. So it works across any modern GPU in the last 5 to 6 years you have, with a minimum of 16 gigs of VRAM. In the future, we may be able to get that lower, but it's once you start going below 16 gigs of VRAM, you start needing too many continuations in the ZK proofs that make it, or segments more generally speaking, that make it a lot more expensive because you're expanding the layers of the tree you need for recursive proving to combine all those continuations together in one proof. But anyway, if you have currently at least 16 gigs of VRAM, you can use the RISC-0 or the SP1 prover. And then this is that ZK operations per second, kind of the generic benchmark we're working on. So it'll show that. You can also look at more details of the benchmark. So different programs running in each ZK VM and each card, see how they perform, see the cycles per second throughput. And then for each GPU, what it's doing behind the scenes. And again, it's not reserving a lot of jobs at the moment because not a lot of jobs are getting submitted by the testing we have. But you can look at this log where it's going in, claiming a job, doing proving, submitting that proof on chain. And again, these are smaller proofs. Normally you'd have proofs that take 10, 20, 30 minutes, maybe multiple hours on GPUs. And so you'd see a lot fewer claims, but then you'd see those jobs running long-term on the GPUs as expensive jobs. Right now for testing, they take like 10 seconds to compute for just end-to-end testing everything. But here you can look at the current jobs in the marketplace. You can go in and interact and claim specific ones. Or if you have more claimed than you have compute for, you can choose selectively which ones to remove if you want to intervene manually. But it's obviously designed to try to act economically rationally by default, so it's not going to claim more jobs that it can fulfill before the claim deadline, things like that. And then this just is kind of already from the dashboard we showed, but how much Hemi you have staked in the system, where it's locked, what job it's locked in, things like that. Collateral utilization. Already went through this. This lets you, again, benchmark performance for each CPU or GPU you have in the system with each of the ZKVM implementations with a bunch of guest programs to get a good mix, because some ZKVMs, you can get different cycle counts depending on whether the ZKVM guest is heavily using some of the built-in precompiles or not, things like that. So it's good to have a kind of a spread of some things that use a lot of the precompiles in the system, some that are just general computing without stepping out of the RISC-V emulation environment into specific precompiles built into that ZKVM implementation. And then it also has the ability to configure what devices are being used, what proof systems are active. You can change the matrix for which proof systems are active for which GPUs. So if you have a GPU that's way better at, I'm just making this up, but SP1 instead of RISC-0 because SP1 is more memory constrained and you're on a 5090, so you have great memory bandwidth or something, you might want to dedicate that just to SP1 proving or something like that. Although the system is generally designed to take into effect the granular benchmarks that you have for each of the ZKVMs and each of the devices you have, and then use that to intelligently choose which jobs it allocates to which GPU, and to engage with the market, decide what jobs are worth claiming because they have a certain profit margin baked into them versus the target GPU that the job is going to run on. And then there's parameters, so how many concurrent proofs you're doing. This is global, so increasing that, in this case, we want that to probably be 3, 1 on each GPU, leave the CPU idle to do the small CPU parts of job assembly. You can also set different parameters for like your electricity costs, things like that, so that it can calculate what your base costs are for computing ZK proofs and not claim a job that's going to cost more to compute than you're getting rewarded for based on your power and the power that measures the devices are using. And then there's also an overclocking section. Also, if you want to change like continuation settings or segment size for GPUs for whatever reason, you can do that. And then you can also do tuning and overclocking, but you do need to run it, at least on Linux, as a sudoer to be able to change a lot of these parameters. But you can change basic stuff like power limit for AMD GPUs, power level, core clock, memory clock levels. NVIDIA gives you a little bit more granularity on Linux for what you're allowed to overclock. But yeah, that's basically it. So that's the ZK proving marketplace, how it works from a front-end perspective, and kind of diving into how the contracts are constructed based on the flow of jobs through the system and how all that works. And then this is the ZK miner that people who are producing ZK proofs in the system would run to contribute compute to the ZKVM marketplace. And yeah, I think that's pretty much it. Any questions? I know we ran 18 minutes over, but and Nabil, it does support the RX 9070. Mine is just too big to fit in this rig because it's like a 3-slot card, so it does work. It's just not on this this test bench.
That was great, Max. Can you go over that whole thing again from the top?
Yep, sure thing. Let me find the window again.
Jeremy, so help me God. No, that was awesome. Thank you so much. And a very unexpected of the ZK marketplace coming very soon.
Yeah.
We are very over time, so I apologize that we can't get to all of your questions today. If there are some that are building related, I have just put up the engineering office hours question channel as well as the announcement. So please feel free to pop them in there. And if they're building related, we can tackle them tomorrow. Join the Hemi Discord server, get some roles, shoot for creative roles, builder role, beta role, all of which have exciting things attached to them. In general and in the future. And I started that sentence and forgot where the hell I was going. And sorry, I have a really, really bad headache. I was on vacation and of course I got sick because it's me. But luckily I didn't get stung by bees this year. So I have that going.
Yeah.
There's still time left.
That's the bar. No, I'm not
You
on
can still
vacation.
have a cat trace track paint through your house too. That could still happen. We can arrange that.
We could probably arrange something like that. I'm still dealing with the tree that fell on my house, so that's fun. But anyway, I digress.
Nabil, I'll keep this quick because I know we're way over. Nabil asked one good question about the ZK market. Can't somebody exploit it by putting an unrealistic time and high collateral? No. So the way in theory, yes, but the way that users are protected against that is the ZK miner. For each job that wants to claim, it'll go through and run it in simulation first, which is very quick. And it'll see how many cycles it takes on the target ZK VM. So it'll see, okay, this job takes, a billion cycles, and the GPU that I'm going to ZK prove it on can do 1,000,000 cycles per second. So it's going to take me 1,000 seconds, plus a little bit to actually, wrap it in a Groth 16 proof and stuff. So call that, 10,050 seconds. And so I'm only going to claim the job if I have enough of a buffer to fulfill that job correctly. So assuming people are running the ZK miner program that has that simulation working correctly, if you submitted a job to the market with a really high collateral that, or regardless of the collateral amount, if it had a really short timeline that nobody could fulfill, then nobody would claim that job because they run in simulation and see that it would take too long to prove versus the timeout of the proof job. The other thing is, and I won't get too into the weeds on this, but there's a way where you can break a job. So when you ZK prove a program, say it has 1 billion cycles, executing the ZK VM guess takes 1 billion cycles in the RISC-V execution environment. What it'll do is it'll break it into chunks of, it does powers of 2 usually, but just to make it easy, like 1,000,000 cycles. And so you'll have 1,000 segments of 1,000,000 cycles each. And so what you can do theoretically as a future extension of this, people could build like ZK mining pools where they would reserve jobs that are tons of compute and on a really short timeline, but maybe have a really high reward for systems that need like near real-time ZK proving. And then that pool could farm out each of those individual segments or continuations of the ZK proof job out to different people to complete, and then it would reassemble those into one final proof. And so you could have something that, would take a single 5090, say, a data compute, but somebody could submit a job with it taking an hour, and a pool that has, say 30 5090s connected to it could claim that job and actually fulfill it in time by farming out each of those independent continuations or segments of the ZK proof and then reassembling it at the pool level and submitting it as a job. So short answer, ZK miner runs simulations to make sure it doesn't claim jobs it can't fulfill, which would filter that. And then longer term, for the actual like legitimate use case of very short proof times, very expensive compute, that could be done by ZK pools or people with multiple GPUs that they combine together to basically break down one proving job into multiple segments and then reassemble it.
All right. I already started my outro, so I'm not going to redo the
Sorry.
whole thing. No, don't sweat it. It's your show, my friend. Jesus. No, but I will say thank you to our incredible community for coming out. Thank you, of course, to the team. Thank you to our moderators, both active and retired. Just a reminder, there is a Rumble session happening on the Hair server immediately following Midweek with Max. And furthermore, please check out Alpha's X posts, and also Alpha, please post a reminder in the Hemi Discord for the Mentora giveaway. He has an incredible promotion running right now for early adopters on his NFT platform. It's a really cool contest, so check it out if you want to. I'm not going to make you, but yeah, I don't know. It'd be pretty cool. All right, well, that's all I got. So we'll see you tomorrow at Protocol Engineering office hours. I'm getting so good at saying that now. I think it's the Dayquil. Yeah, let me kick it over to Max and the gang for any outros they may have. I'll shut up now.
All right, cool. We're way over time, so I'll keep it quick. Thanks for joining us. Definitely join us tomorrow for the Protocol Engineering office hours. I got it right too. If you have any building questions, want to discuss anything you're working on or want to work on, or talk through designs, anything like that. And so looking forward to seeing some of you there and the rest of you next week at Midweek with Max as usual. And also stay tuned. The ZK Proving Marketplace is coming closer to public testing. And so that everything I was just demoing, not sure on the exact release date, but relatively soon we want to get that out into the beta testers channel for people to start playing around with, giving feedback. There will be some incentives around it, not like a full points program type thing, but more of, if you find like a legitimate bug or have good feedback or something, and then there'll be some like base participation rewards for people based on how much ZK proving they do in the system to kind of prove that they're testing it out. And so, yeah, stay tuned for that. And we will see you either tomorrow or next week. Appreciate everyone coming out.
Thanks, y'all.